Okay, so we're on page 11, the bottom half of page 11. At t equals 0, Lenny purchased a portfolio of 12 1,000 par value bonds. Okay, 12, and they're all par value. For 10,586.61. The bonds are 6% with annual coupons. The 12 maturity dates are t equals 5 through t equals 16. Find Lenny's yield rate. So why don't we begin by setting up these bonds? How about bond number 1? What does that look like? It matures at t equals 5. So let's have 5 here. And annual coupons. 12 1,000. Okay, so F equals 1,000 and 6%. F equals 1,000 and R equals alpha 1 equals 6%. So the first year it's going to pay a coupon of 60, and the second year it's going to pay a coupon of 60, and the fifth year this continues, coupon of 60. And it's a par bond, so not only will it pay 60, but it will also pay a redemption of 1,000. Agree? Now let's go to the second bond. We set up this pattern. This bond matures at t equals 6. So at 1 you have 60, at 2 you have 60, at 5 you have 60, at 6 you have 60 plus 1,000, redemption of 1,000. And this continues. We've got how many bonds?
12.
Right, so bond number 12. You have a problem like this on your take home, right?
Yep.
At 0, at 1 you have 60, at 2 you have 60, and this continues all the way to times 16. You have a coupon of 60, and you have a redemption of 1,000. So what about the total? Can we make a line, a timeline with the total now? Total portfolio. So how much do I have in coupons at time 1?
720, 60 times 12.
Right, 60 times 12, so 720. And at time 2, again 720. How about time 4? 720. Time 5?
Redemption now.
Now I have the first redemption, right? So 1,000 plus 720. Times 6? Careful now. Just look at those timelines. You lose a 60,
Yeah.
right? 60, but you have 1,000
Still.
and you have 720, but you lose a 60. And then at time 7, you lose two 60s. You have a 1,000, you have a 720 less 2 times 60. Got it? Continue this process. At time 16, you have 1,000, 720, minus, you've lost 11 60s. Okay, so how about you could do a time 4 equation of value, or you could do a time 0 equation of value, whatever you prefer. What do you think? Time 4? Let's start with a time 4 just to play, right? So we're here. Time tau equals 4. Equation of value. How much did he pay for these bonds? Lenny?
10,586.
Right. So let's start there. Minus 10,586.61. We're bringing this price. Here's his price. Bring that to time 4. So let's grow that. 1 plus y to the 4th. Right? He paid that, so it's negative. Plus, how about these 4 720s? 720. I want the accumulated value of an annuity, 4 payments, right? So 720 S angle 4 Y plus, how about these now? Yep, arithmetic. Increasing or decreasing? Decreasing. And what's the first payment?
720.
Right. 1720.
With this 1,000.
Right? So I P Q A, right? Angle how many?
11?
12, because you go 16
Oh, to 4, right?
minus 4. There's no payment at 12 at 4, right? There's no payment at 4 that I'm including for the increasing. So A angle 12 at Y equals 0, where P equals 1720. That's my first payment. And Q, the increment, is negative 60. Got it? What's your question, guys? What about a time 0 equation of value? Had I chosen to do that, what would it have been? Time tau equals 0, equation of value. Let's bring everything back to time 0. What do you say? Minus 10,586.61. That's happening at time 0. Plus, now it's positive because the coupons are coming in. 720. A angle 4. Y. Plus, I. P. Q. A angle 12. Y. Where P equals 1720 and Q equals minus 60, but this time I have to discount it because this present value is at time 4, but I have to bring it back. Yeah, got it? 1 plus y to the minus 4 equals 0. Go from gave me y equals 0.0775. Got it? Any question? So just step by step setting up and keeping focused and you can get this done, right? What about something like this? This is a cop-out, but you could have done this. 10,586.61 equals 60 A angle 5y plus 60 A angle 6y plus cop-out, right? Plus 60 A angle 16y plus 1,000. Now there's an annuity of 1,000. A angle 12y 1 plus y to the minus 4. Could have done that too, but it's like really lame for people. You guys know what you're doing now, right? Good?
Can you explain 1 plus y to the minus 4?
This one?
Yeah.
Yeah, so you see this increasing, it's actually decreasing, but it's IPQ. This one has its present value here. But I don't want the present value there. This is a times 0 equation. So I have to bring it back 4 places. We're just counting 4 places. Okay, next page. So next page is all about callable bonds. So what's a callable bond? Anybody know? What does it mean to call the bond? So let me back up a little bit. You know, when you take a mortgage, right? You can decide to refinance that mortgage and say to your first bank, your coupons were too high, the payments were too high, your interest rate was too high, and therefore I choose to just return the money to you and take my mortgage someplace else. We do that all the time, right? You take a mortgage at 6%, the rates go down to 2.5%. You want to refinance and tell the original institution, no more. I want to give you your money back and I want to do my business someplace else. This is the same thing, except the person, the entity that has issued the bond is now saying to you, I don't want to pay you your coupons anymore. The deal is off. So I'm not going to pay you your coupons anymore. I'm going to give you your redemption earlier, and I may have to give you some kind of a premium for doing that. So that's called a call premium, meaning they're going to give you some extra amount of money because they're stopping this deal with you. Okay, so let's read. It's very clear and concise, this little blurb. So it says, a callable bond is a bond that is redeemed at the issuer's option. So that's important because this is as opposed to a puttable bond, which is at your option. So a callable bond is at the issuer's option at a time before maturity. So it doesn't allow you to go to the end. He just calls it in whenever he feels like it. This makes the realized yield difficult to predict, since that would depend upon the bond when the bond is actually redeemed. Callable bonds offer higher yields. Why? They have to offer higher yields because that other company has the right to call what they want, which leaves you at a deficit. Because if they're going to return your money to you, let's say it's a $100,000 bond for which you paid $90,000. It's a discount bond. And they decide to return this money to you, probably because interest rates went down and they don't want to continue to pay you higher coupons. So they return your $100,000, which is a redemption, to you early. But now you're in this state where you're left with your $100,000 X number of years earlier than you had anticipated, and you can only reinvest your $100,000 at a lower interest rate because now interest rates have dropped from, let's say, 5% to 2.5%. So that leaves you in this predicament because you're not able to reinvest your money at the rate that you thought it would be invested at, which was 5%. So because of that, normally a callable bond will offer a higher yield to you to compensate you for the fact that they might be calling it in early. So callable bonds offer higher yields than non-callable bonds, since the option to call in the bond is an attractive feature for the issuer, providing him flexibility and to the detriment of the bondholder. So he's not doing you any favors by selling you a callable bond. The higher yield is to compensate the bondholder for this. You're the bondholder. If interest rates drop, the issuer of the bond may call in the original